Okay, so let's go ahead and talk about percent composition. Um, Composition just means what something's made of. So if I asked you what the percent composition of your t-shirt was, you might say 98% cotton and 2% polyester or something like that. But percent composition refers to the percent of each element in 1 mole of a compound. And so it has a formula that goes along with it. That would be right here. Okay, and this formula refers to the percent, and you put the grams of the element over the grams of the compound. And that is done by doing step number 1, which is calculate molar mass. Okay, so if we're looking at number 1 is specific with its question. It says what percentage of copper 2 bromide is copper? So that means in our formula, the grams of the element, we're going to try to figure out, okay, how many grams of copper are in the total grams of the compound, or the total molar mass, times 100. And so first we need to convert copper 2 bromide to its symbol. So copper is Cu, and this Roman numeral 2 tells us that it has a +2 charge. Bromide, anytime anything ends in IDE, we know it's talking about a non-metal on the periodic table, so that means it's talking about bromine, and it just had the ending changed. And bromine is in column 17, so it has a -1 charge. +2 and -1 do not cancel each other out. They're not equal but opposite, so we have to cross and drop. And remember, when we cross and drop, it's the number that's crossing over, and we're dropping the negative sign. And so the 2 will come over here. And chemists are really lazy, so we don't write 1. So the way it would be written out would be CuBr2. And so if we want to calculate the molar mass of this, we would just list out our elements. So we have copper and bromine, and we have 1 copper and 2 bromines based on subscripts over here. And what we're going to do is we're going to multiply them by their atomic mass on the periodic table, because we don't know how much all of copper bromine weighs, but we do know how much 1 copper and 1 bromine weighs. If you look at your periodic table and you look at copper, it has the symbol Cu, and underneath it you'll see an atomic mass 63.55 at the bottom. So 1 times 63.55, and then 2 times 79.90. And when we multiply those out, we get 63.55 and 159.80, although that 5 looks a little messed up. So let's redo that there. Okay, and then we add them all together to finish up our molar mass, and we get 223.35 grams. Okay, now notice that specifically we're looking for copper. So we see the total amount of copper is 63.55, and the total amount of copper bromide is 223.35. And so those are the numbers that we're going to put into our formula. So my percent copper is going to be equal to 63.55 grams of copper divided by 223.35 grams of copper bromide times 100, and that will give us a total of 28.45% copper. And that will be our final answer. And so percent composition is just breaking it down. And so if we're looking at something like number 2, where it says what is the percent composition of sodium hydroxide, sodium hydroxide has a formula of Na plus 1, and then hydroxide is a polyatomic ion on the back, it's OH minus 1. And so they cancel out, so it's just NaOH. And when it's not asking for any single one in particular, that means it's just looking for what is the percent breakdown of all the elements. So first thing is going to be calculating the molar mass. So NaO and H, we have one of each. Sodium is 22.99. Oxygen is 16.00 and hydrogen is 1.01. And because we multiplied them by 1, it doesn't change anything. So 22.99, 16, 1.01. And when we add all of those together, okay, I just don't have room to do it underneath, we would get 40.00 grams. And so that means we're going to use our total amount of sodium hydroxide, and we're going to break it down by each individual element with our totals of those elements. And so for sodium, we know that percent sodium would be equal to 22.99 divided by 40.00 times 100, and that will give us 57.5% sodium. Percent oxygen would be 16.00 divided by 40.00 times 100, and that will give us 40% exactly. And then our percent hydrogen would give us 1.01 divided by 40.00 times 100, and that will give us 2.5% hydrogen. And so our final answers would just be all three of those. So I'll highlight them in blue. My three answers would be these right here, okay, because they didn't specify any particular one. So that's how you do percent composition, and you have several more problems, 3, 4, 5, and 6, which you should have done yesterday, but I forgot to upload the video. So if you didn't get it, here it is now.